Hello, everybody. Good afternoon. Welcome to this webinar that we are doing. We are GSP, and we're doing this for Caribbean Motor Spares. I would like to welcome everybody. If you're present, if not, you can invite your friends, family, whomever. My name is Andres Caicedo, and I am the Chief Engineer here for GSP Latin America. So today we're going to talk a little bit about CV joints, the driveline products, and without further ado, let's get started. I like to start with a video because it shows everything about the factory. It shows the procedure of the CV joints. It will show the manufacturing processes, which we're going to talk about. So that way we have a kind of visualization of the products that we are going to talk about. All right, hello everybody. Welcome back. Let me. Perfect. All right, good morning. For those of you that have joined in the time since, again, my name is Andres Caicedo. I am the Chief Engineer here for GSP Latin America. And joining me today is my coworker, Rafael Rodrigues.
Going in this.
Yeah.
Good morning, everyone. We want to thank you for your time and for joining us in this seminar. That Andres will be speaking about our CV joints and installation, and also all the any other tips that he'll be able to share with us on this on the CV joint, in which on the following couple of weeks we'll do another one in shocks, which I think would be very worthwhile for everyone to take part in, and hopefully today he'll be able to teach at least one new thing from that we can walk away from, doing a minor improvement on how do we install the CV joints and be able to maximize the life of our CV joints. Thank you very much. I'll pass it on to him. Appreciate it.
Thank you very much, Mr. Rodrigues. All right, so before we get talking about our parts, let's talk a little bit more about GSP. GSP as a whole, we are a multinational corporation, and GSP is the worldwide leader in the manufacturing of auto parts. Worldwide leader. GSP has 5 offices worldwide, and each one of these offices is going to have a warehouse in order to be able to store product locally. So we have our headquarters in Wenzhou, China, all the way on the far east. We have, for our European division, we have an office in Cologne, Germany. For our North America division, we actually have 2 offices, one on the East Coast in South Carolina, and on the West Coast, we have one in Los Angeles, in LA, California. For Latin America, which is in South America, Central, and the Caribbean, we have our office here in Miami, Florida, which is where I work with Mr. Rafael. So in 2014, GSP constructed our own factory. Why? Because we were running out of space. We were running out of time. Our machines just weren't producing what the market demanded. So we built a new factory. We bought new machines. We bought new toys. And our factory, the size is 300,000 square meters, which is just a number. So to put that into context, here is the current picture of our factory in Nanjing. This down here is a lorry, a cargo truck, an 18-wheeler. So in comparison, we can see already how big it is. And on the top right, we're still missing this quadrant to finish constructing. So we're getting there. Again, for our factory, the benefit of constructing your own factory is that you can design it how you want. You can put stuff where you need it and not where you want it, right? So if you have the raw material coming in here, it makes sense to have the manufacturing here, and then the heat quenching here, and then the production, and then packaging, and then shipping. Everything's in a linear line, makes the logistics that much easier. Production capacity, these are numbers per month, ladies and gentlemen. And we don't do these numbers just to say that we do them and we're the number one in the aftermarket in producing these numbers. No, we do this because this is what the market demands. Worldwide, these are the numbers that the market demands. So as you can see, CV joints, 1.1 million per month, CV axles, 300,000, hub assemblies, 450,000 per month, and shock absorbers, 830. There are other lines that we carry as GSP, but these are the biggest numbers I wanted to push out there. So at the same time that we built our factory, we also made apartment buildings for our workers, because most of our workers come from different areas of China and they're very far away from their families. So in order to give them a sense of community, we have apartment buildings, we have a shuttle that'll take them to the factory and bring them back, and just to improve their quality of life. Happy worker, happy company. So again, most factories will be along the coast because of terms of logistics. It's closer to the port, right? So most of our workers will come from the north or from the west. Yeah, from the west, from inland China. All right, CV joints and CV axles, which will be our topic for today. CV axles. The main purpose of a CV axle is to transfer power from the transmission to finally the tires, right? So on the far right-hand side of our screen, we see the end of the axle, the inner CV joint, which is going to go into the transmission. So power goes from the engine to the transmission, transfer through the axle to the outer joint, and connected to this outer joint will be the wheel hub, and from the wheel hub will be the wheel, the tire, which is how you get your traction and how you get your vehicle to go forward or backwards. So our CV axle, the GSP, we design them and manufacture them with super high tolerances, right? You need tight tolerances so that there's no space in between items. As soon as you have space in between items, you have knocks. We're going to talk about that in the next slide. And smooth bearing movement in the joints. So the different components of a CV axle, and the reason I mentioned the tight tolerances is because of all of these different parts. You have your clips, your chaining clips, your seals, your connections, clamps, your bearings, your cages. You don't want those items to be knocking against each other, and that'll happen when you have either loose tolerances or your CV joints will start to degrade. The two areas of focus, right, are our CV joints. So we have our inner CV joint on the right-hand side, which goes to the transmission, and our outer CV joint to our left that goes to the wheel. So the moment that these bearings start knocking around is when our CV joint is going to start to suffer. The grease that we use at GSP, very important as well. It is a molybdenum disulfide. It is very good in high temperature and high lubrication. It is slightly better than the graphite grease that is normally used. And this grease we import from Japan. And the reason we do that is because we're a manufacturer of solid parts, of iron, of metal. So the grease we actually import, we outsource, but we get it from a factory that this grease goes directly to OE applications. So it'll go straight to the Toyota, straight to the Nissans, those high-end cars. And we use that grease because of its properties. All right, CV joints will also come with an ABS ring on the outside. As we know, it could have teeth, as we see in the image below, or with little windows. And those are very important because we're going to have a sensor on the far right of the screen. I don't know if you guys can see my mouse. I hope you can. There's a signal, the ABS reader, which is going to read and it's going to look for that ABS sensor ring, right? The toner ring, the tone ring. If it's not there, we're going to get the little triangle ABS on our dash. And the reason we want to have ABS is obviously because of safety. If your vehicle comes with ABS, what it's going to do is it's going to be an anti-skid system. ABS standing for anti-lock braking system, right? So the moment that we press the brakes, we're going to have a pulsation. The brake calipers are going to open and close very fast. They're not going to clamp down because the moment we clamp down is when we skid. So to prevent the skidding, it'll pulsate super fast and it'll cause the wheel to stop. In this picture, we can see, right? So the gray line will be the moment that we apply the brakes. On the top, when we have ABS, we're going to avoid the obstacle in the road. It could be a tree. It could be a kid playing in the street. It could be an animal. It could be another vehicle. It could be a pedestrian. We are able, as we're stopping the vehicle, we're able to turn and we're able to avoid that obstacle. On the bottom, we can see the same scenario. When we apply the brakes, you can see the tires in the middle image, they're turned. But because the brakes locked up, the vehicle is going to travel in the same momentum it had, which is going to be a straight line, and we're not going to be able to avoid whatever it is on the road. So going back to the image, this sensor also applies to wheel hubs. I know we're not talking about wheel hubs, but I just want to mention it really quick because the sensor is always going to be looking for an ABS if your vehicle is equipped with ABS. Now, in terms of installation, if you purchase a CV axle or a CV joint that has an ABS tone ring and your vehicle does not require it, you can leave the ABS on. Why? Because there's no sensor that's going to be looking for it. So you're not going to have an issue. The clearance is still going to be there. So you're not going to have any interaction with any other parts of the suspension. So instead of trying to bang it out with a hammer and messing something up, just leave it. It's absolutely fine. It's not going to interfere in anything. The same animation we saw. For our CV joints, what we do as well when we finish manufacturing the bar is we are going to align it. We are going to make sure that it doesn't have any wobbles, that it's spinning completely straight. So we're going to attach both ends and it's going to spin. And as we saw in the video, where it senses the deflection of the CV axle, a machine is going to come down and stamp it with a little bit of weight, or it'll deflect it. It'll push it down to get rid of that kink in the axle, and it'll spin again until it reaches a point where it doesn't wobble anymore. Why? We don't want to install a CV axle, and the first thing we sense is again a vibration. For the heat treatment of the CV axle, this is to prolong its life. Why? Because we are going to harden the metal through a chemical and heat treating process. So on the top, we're gonna heat the inside of the outer joint. It's gonna be the race where the balls are gonna go. The bearings are gonna slide, I'm sorry. And we're also gonna do on the splines. Down here, we can see the splines. And why? So that when they're in contact with the wheel hub, they don't strip. We don't want anything to strip. So at GSP, we're gonna do a heat treatment on the splines of the CV joint and on the inner splines of our wheel hubs. Why? Double treatment, double hard, we're not gonna have anything fail. Perfect, I also wanted to show this image as well. On the inside of our ball joint, we're gonna have the track where our ball bearings are going to move along, right? The next time you have a CV joint and you take out the bearings, the race, and the cage, you can slide your finger along the tracks. And you're gonna notice a difference between GSP products and our competitors. At GSP, they're smooth. Our competitors are not. Why? Because we go an extra step and we grind it down to make sure that the track is smooth. If it's not smooth, the bearings are gonna jump along the track. You're gonna get grease caught in there, so it's not gonna do the proper lubrication, and the CV joint is not gonna last as long as it should. Again, as we saw with the heat treatment, first we do the heat treatment and then we grind it and mill it to make sure that it's an optimal product. And on the right-hand side, we can see two examples of heat treatment because heat treatment is very important to the life of the part. When it is done correctly, it will not reach the edge in such an exaggerated manner as it does on the bottom. On the bottom, because of the exaggeration and the distance that the heat treatment was done, that part is burnt, right? When we overheat metal, it is prone to cracking. As soon as we do excessive force on it or any type of force, it's going to crack. So the bottom CV joint is not going to last as long as the top one because of the heat treatment. At GSP, we do concentrated heat treatment. It's not erratic, as we see on the bottom left as the example. It is done correctly. Again, with the depthness. The depth of the heat treatment. There you go. I'll change the sentence around. On the left, we see the OE design, which has a certain distance of the thickness of the heat treatment. And on the right, at GSP, we did a couple of tests on it, right? We played around with the different depths to see which was optimal. Once we found this optimal on the right-hand side that we can see, we contacted the manufacturers, right? So for example, for Toyota, no, let's use Volkswagen because Volkswagen is in China and they have a specific line just for China. We contacted Volkswagen and we said, hey, Volkswagen, the CV joint that you guys sell, we noticed that originally you have this type of depthness, and we played around with the numbers and we came out with this depthness to be a little bit better. The product is gonna last longer and you're gonna have a better experience. So what does Volkswagen say? Prove it, right? Talk is cheap. Prove it. So that's when we send the parts, we send the results of the testing, we send all our drawings, all our CAD drawings, computer drafting, right? Computer aided drafting to be able to prove this. We're going to talk about this later as well. Right? So other components inside the CV joint that have to be manufactured to a level that is a premium level is the cage. If the cage is not smooth, then the bearing inside is not going to be able to have the optimal displacement, and it's not going to do its job, and we're going to lose life on the CV joints. Also, if the material of the cage is not optimal and the dimensions are not right? So if a company wants to cut corners and cut cost, they will make this cage thinner. Once it's thinner, it's not to always spec, and it's not going to last as long, and we're going to have a defective item. The bearings. The bearings are also important. Even though it's the smallest part of the CV joints, it is very important because it has to be smooth and it has to be round. We don't want a football shape or a rugby ball shape in there because it's not going to be a smooth transition, right? So at GSP, we give it an acid bath to get rid of any defect on the top and to avoid peeling. We see this on the right-hand side with some ball bearings of our competitors that they don't go through these processes to make it smooth, which you can do by sandblasting. And after that, we give it an acid bath. So you'll see in some metal structures, for example, in the bearings for this example, that it'll start to flake. And we don't want that, obviously, because that introduces dirt and grime into our CV joint, which is exactly what we don't want. These are some tests that we do on our CV joints, and we'll do them with the boot on, obviously to test the boots, and we can see the rotational speeds at which we try them, the duration at which we try them, and different temperatures and different angles. So at 10-degree angle inclination, 35, 10, 40s. This is to make sure that our product is optimal and it's good for all terrains. Our products are one single quality and they are shipped worldwide, right? So the CV joints have to perform in China, they have to perform in Australia, they have to perform in the US, they have to perform in Guyana, they have to perform in Brazil, Argentina, South Africa, Germany, Spain, France, you name it. It's just one quality worldwide, and it has to fit, it has to blanket all of those different types of driving. Hence, we have these types of tests on them. Right, so some common failures that we see with CV joints. We're going to talk about these three: incorrect use of tools, incorrect procedure at the moment of installation, and incorrect vehicle application. So for the first one, for use of tools, as you can see on the right-hand side, you got to have the right tool for the right job. The moment that let's use this one. At the moment that we want to install our CV axle nuts, it is very important to do it correctly. And how is it correctly? By not using impact guns. Impact guns are the worst thing for any component on the vehicle. Why? Because we are going to very easily over torque that part, whatever nut we are going to install. Let it be for the shock mount, or the CV axle nut, or the wheel hub lug nuts, or any type, for engine mounts, for example, anything. What is the problem with over torquing the system is that we're going to introduce stress, as we can see on the bottom left. And stress is going to propagate, and it is going to find the weakest link of your system in the suspension. And that stress is going to propagate, and it's going to break at that weakest point. Usually on a CV axle, usually on a CV joint, the weakest points are when you go from a very big diameter to a very small diameter. In engineering and in science, as in physics, this is considered a weak point. So let me see if I can zoom in on that. That is why at GSP, as you can see here, the whole shaft is heat treated, because we see that this right here is going to be the weakest. It's going to be the weakest link. Why? Because we're going from a very big diameter and we're changing drastically to a very small diameter. The reason we need this is because this outer diameter is going to be the seal that's going to go into the steering knuckle. So that's why it cannot be tapered. So what do we do at GSP? We heat treat it to make sure that that part doesn't break. So the moment that stress is going to accumulate in the part because of over torquing this nut with an impact gun or just not torquing it down to spec, that's going to be our number one stress point in that CV joint. Another problem of over torquing is that this nut is going to start to pull the CV joint out, and we're going to have one of two things. One, the clip that goes on the inside, the C clip, could come off, even slightly. When that happens, we're going to have the CV joint break. It's just a matter of time. The second thing that could happen is we're going to pull the inner joint off the transmission ever so slightly. And ever so slightly in a system where we have an engine that is producing multiple horsepowers, that's going to be a huge, huge problem. So things to keep in mind: please do not over torque any type of part on your vehicle. Second common issue is incorrect procedure, right? So as we can see in the image, that is not correct for many, many, many reasons, right? So the moment that we are uninstalling and the moment that we are installing, we have to make sure that it is done correctly in the way that it should be, right? We're not going to try to take off the shock absorber without taking off the wheel first. That's just common sense. But we have to follow these steps, and we have to make sure that we are actively recognizing that we have to go in order. Why? Because we don't want to mess up anything else, right? So for the example, if we're trying to take off the shock absorber in this case without taking off the wheel, we're going to mess something off. We're going to mess something up. So we obviously don't want that. Another type is incorrect vehicle application. As we can see in the image, that is not the original intended use of that vehicle. Yes, it's a pickup truck, and yes, it's meant to haul or pull things along, but it is not meant to be overloaded. Another one is to use the part for the original intended vehicle. Yes, it is very common to find a CV joint that may have the same dimensions in spline, length, seal, and the inner teeth for different vehicles. But if it wasn't intended to be used like that from the factory originally, we're going to have that part fail. We don't know if the torque of the engine is going to be the same. We don't know if the turning radius is going to be the same in the same vehicle. We don't know if the displacement of the suspension is going to be the same, right? If we have 3 inches of travel, or we have 5 inches of travel. Just those 2 extra distances, as we know with trucks, for example, makes a huge, huge difference. And we're going to have that CV joint, again, be under stress. We're going to have it be pulled out of the CV axle if we break that C-clip, or it'll be pulled out of the transmission on the inside if we have too much play and too much stress on that part. Again, so just referring to this image, the moment that we overload it, I don't want that driver of that particular truck. I have no idea where this picture is from, so don't think that we know him. We don't want him to go and say, oh, look, I just installed your new GSP CV axles or your brand new GSP wheel hubs. I took it around the block and it failed. Just by looking at this picture, that is not the original intended use of that pickup truck. The same thing applies to passenger cars. Some other common failures are full steering lock of the steering wheel, right? So the moment we're driving and we need a turn, we turn and we hit that, and we hit the end of the steering, right? It locks. Yes, you can do it and maneuver in or out however you need, but don't leave it locked for extended periods of time. Why? Because the moment you hit that end, your suspension on one side is going to be stretched to the maximum of its maximum usable range. If we drive with the steering lock for a longer time than normal, we may cause more stress on the system that we need to. Large suspension travel, the third one that we see here. Again, going back to pickup trucks, to work trucks, or even a vehicle that's just a little bit lifted, if you go beyond 2 or 3 inches, that is already too much stress on your system. If we want to lift our vehicles, yes, obviously we can, but then that will require aftermarket and performance parts, not OE anymore, because that is not the original intended use, nor the original um, suspension travel length of the system. And going back to the second one, the torque warp on a CV axle. This is very interesting, and it was very fun to read the report. It was a shame that I wasn't part of this. This was a test done in North America. Why? Because there is a huge racing division in North America, as most of you may know, right? We have Indy, we have NASCAR, we have stock racing, we have truck racing, we have um, GT 1, 2, and 3. So there were some companies out in California that wanted to use our CV axles, and we gave it to them. We said, fine, here, we'll sponsor you. But our axles kept breaking on these racing cars. Racing cars, not street cars, racing cars. So they kept breaking. So GSP said, all right, let's do a test. They grabbed the CV axle, the one on the bottom, and they painted a line red on the outer joint, on the shaft, and on the inner joint, and said, let's do a test. Let's see what your car is doing. Let's see how much torque your car is producing. So they put the car on a dyno, on a dynometer. That's it says how much power output your vehicle has to the wheels. And they grab the number. Boom, perfect. Thank you so much. That is much higher than OE. Let's see what happens out on the racetrack. They install the GSP CV axles on the car. They take it a couple of laps around the track, and they noticed something when they took the CV axles off. There was some warp on the joint, on the axle, and on the outer CV joint, inner shaft and outer CV joints. Why? Because more torque was being produced, because that car was no longer OE, right? It was designed for a racetrack. So OE axles did not perform. And it's no surprise. The vehicle was modified extremely for the racetrack. The suspension was completely different. The control arms, the shock absorbers were coilovers. The bushings were all neoprene. The engine had a twin turbo installed. It had it was water cooled. It had it was water cooled for the oil, right? So it was no longer stock. This was a legit racing car. So this goes back to use the parts as intended by the original manufacturer. Once you want to get into these crazy things like racing, off-road, and lifting your suspensions, that's when you're going to need aftermarket performance parts. That was kind of a long story, but it was a pretty cool story. All right, so why GSP? Our quality, as I mentioned during this whole presentation, the quality of our parts are meant to be used as original replacements. These are aftermarket. These are not performance. The experience, GSP has been around for 35 years. So we have made mistakes, we fixed them, which is why we're at the top of our game. There's a reason that GSP is #1 manufacturer in the world, right? Our engineering team, which thankfully I'm a part of, our certificates, ISO 16941 and 14001. The 14001 is for terms of logistics, right? So this is more for the distributors. When GSP says, yes, we're going to ship you 10 containers, you get 10 containers. You don't get 5, you don't get 3, you don't get 7. You get what we say you are going to get, right? And why do I mention this? Because there are some factories that will say, yeah, I can ship you 10 containers, and at the end of the day, you only get 7. So then the customer is short. The ISO 16949, which just changed to a TSI 16949, is for the quality of the product. Having the certificate means that you can sell these parts to the manufacturers, right? And the catch, where do I don't have it. The catch for this is that each part requires its own 16949, right? So I have an i6 16949 for my CV joints, inner and outer. I need a separate one for my CV axle. It's the same product, but it needs a different. I mean, it needs its own certification because it has to to meet all the requirements. So I need a different one for my wheel hubs. I need a different one for my shock absorbers. I need a different one for my control arms. I need a different one for my engine mounts. And why do I mention this? Again, because some factories will say, oh yeah, I have the 16949, and they sell you all those items, but you need to make sure that they meet the 16949 for all the items that they're saying that they want to sell you, and not just for one or two. Again, 35 years in business. And the base materials, the grade A base materials. So GSP buys the best materials, and then we mix with other materials. Why? To have a completely pure part will be way too expensive. So what we do is we play with the metallurgy to make sure that the product is still optimum, it meets or exceeds OE, and it is still at a price for our consumers. So base materials, they are fantastic. We get them from the best for steel in China. We buy the grade A, as we can see here. There's different grades. There's grade A, there's double A, there's triple A, and then there's lower than that. But we buy the best. State-of-the-art machinery. Again, with new factories, we get the best toys, and we need those best toys in order to produce the parts to the tolerance that we need. As we saw in the video, we have a lot of automated machines. Why? Because these machines being automated, they're robots, and they will do the exact same maneuver every single time. It's not the same as a person trying to line up the center of this part to punch it with a die, as it is a machine that's going to grab a laser and say, this distance, they intersect here. That is the correct center. It's true center. Let's punch it right down the middle. It's going to be perfect every single time. OE specs of the product, again, these are meant for OE applications. Whenever we want to develop a new product, right? So let's say that there's a CV joint or a CV axle for a vehicle in the market that we don't have. We go to the dealership, we buy the CV axle, and we develop it. These are all the steps that we are going to go through, that GSP is going to go through. And as you can tell, well, not that you can tell, but we have when it's okay to go from one step to the next, we have an okay. When it is not okay, we go back to the previous major step to make sure that we do it again. Sorry, a little bit of Cuban coffee. And the reason we have all of these NOKs, not OKs, is redundancy. Why is redundancy good? It makes sure that the product is optimal. We could have just one not okay at the end and go back and do it all over again, but we're not going to be checking every step of the way. This checking at every step in the way, yes, it is redundant. Yes, it is more time. It is more money. It is more personnel. But we want it at GSP. We want it. Why? So we can have the best part for the market. There's a reason we're number one, guys. There's a reason we're number one. Our service, professional and multilingual. So as we saw, oh, I don't have the map. As we saw at the beginning with the map of the world, we have 5 offices worldwide. And why do we do that? To make sure that there's someone near you that speaks your language, right? So for Latin America, I speak Spanish, English, Portuguese. If there's a problem anywhere in Latin America, I can go, right? So I can go to Guyana, I can go to Barbados, I can go to Puerto Rico, Brazil, Argentina, talk with the customers, see what's going on. If something failed, why? I can be there, I can take pictures, I can take video, I can write a report in English to be sent to the factory where we take care of the problem. Obviously, from English to Guyana, it's not that big of an issue, but for the rest of Latin America, it is. So in Europe, if we have someone go to Spain, or if we have a problem in Portugal, or in France, or in Germany, there's somebody there close to the action, close to you, that can translate from the local language to English to be able to speak the same language with our factory. Where is GSP going? What are we doing to maintain our status as number one? First to market. What does this mean? When a vehicle comes out, right, a model for 2020, we want to have that part. We want to have that part so that the end consumer can already have that part if it fails. Yes, the first couple of years, parts are covered by the dealerships, but in some countries, in most countries in the world, actually, to get that part, even from the dealership, it'll take a couple of weeks, weeks to get that part shipped over from the factory to the dealership. So if GSP has that part, GSP will offer that part to the dealership already. It's called Original Equipment Supplier, OES. Again, it's the same part. It's being sent directly to the dealership and being installed. Why? Because we are OE spec. We meet the original equipment manufacturer specifications, and we are OEM in most cases for most of our products. We buy our samples from our dealerships, right? Why? We don't want to buy aftermarket. We don't want to buy someone that already copied the original, because most companies out there do not stick to the dimensions of the original manufacturers. They will cut corners. They will try to cut corners instead of making the thread the distance it has to be. They'll make it shorter or longer if they find another CV joint that's close to it. That's going to affect the installation of the part, and it's going to affect the longevity and the performance of the vehicle. Why? Because it's not OE. Even if the threads are a little bit further inner, it may affect how far this nut is able to be tightened, and then we're not affected in a way that we won't be able to get to the locking mechanism which we have here, right? Or maybe they'll put it further in or further out, which will definitely affect everything in the suspension. Technological support. For Europe, we use TechDoc. For North America, we use WHI, and worldwide, we use TMOT. These are members that have a very vast cataloging system, so we're able to find the part that we need for the application that is needed. Again, for development, worldwide, we use forums. This is more at the distributor level. We have, for our companies, we have an engineering department, right? So we're able to go in there, we talk about parts, what's needed in the market, if the spline count is wrong, if it's right. For French vehicles, for example, I know it's a huge issue because they have different splines and different diameters, even though it's the same application, just depending where it was made. If the vehicle was made in Latin America or in Europe, but they're both sold in both markets. So we're able to talk a little bit more about that, market research, and just technical information overall. And with the CV axles that I was talking about, with being over torqued, GSP sponsors ATV races here in North America. And that's the reason why I wanted to mention the CV axle deformation and the project we did. Because using that information, we were able to develop a CV axle that was perfect for these vehicles. As we can see on the ATV here, these are called ATVs or UTVs, or side-by-sides, right? So we played around with the materials, as I mentioned again, right? So we use a different type of steel. We use 4330. We use a chromoly, which is a mixture of different metals. Why? To make sure it's 30% more resistant than OE. We don't have that warp, because again, these vehicles are designed for racing. It's not meant for a farm anymore. It's not meant to be used around the countryside to get from one town to the other. These are racing specific vehicles. We made our CV joints larger with more angle and more flex, right? So that way we don't have that deformation. When we have that over torque, they're able to flex a little bit more, which works wonderfully for these ATV applications. We also have them for these type of ATVs. I'm not sure what they're called in Guyana, but that's why I included the image, so that way we're on the same page. And again, the grease is going to be the same because it's OE, and if it works for cars, it's going to work for these. They're meant for high temperatures, high velocity, and high impact, right? For extreme usage. And the boots are going to be upgraded. They're going to be TPE. They're not going to be neoprene anymore. So just a little bit of what GSP is doing to maintain their status as #1. And with that, ladies and gentlemen, I want to say thank you for your time. I hope everything else is clear. Let me see if Simone, do we have any questions? Anything we can clear up?
No.
Mr. Doobay, I don't know if you can permission to talk.
Oh, okay. No, we don't have any questions yet. If you guys want to do it, it's the time. In the meantime, we're showing here the pages of GSP Latin America. You can follow us also on Facebook and Instagram. We have a GSP group LinkedIn page and also YouTube. We have great videos there for also GSP North America posts some videos, installation videos there. You guys could have a look. So yeah, this is it. I believe nobody has any questions, Andres. But regardless, you can always email Andres. I think Mr. Hardial has direct access to Andres' WhatsApp, and he can also you can ask him, and then he will set out the questions about that.
Okay, I had a question here about the discoloration of the CV joint, right? Because it's not completely in silver all throughout. And on the bell, we also have these discolorations, these dots. This is part of the heat treatment. The next time you have a CV joint in your hand, you're going to notice that each one of these dots, each one of these burn marks, it's going to correspond to one of the bearings. And the reason is that we want the area in which the bearing is going along the track on the inside of the bell, which is where the bearing is going to be doing its movement. We want that metal to be reinforced. Obviously, metal is already hard, but if we make it just that little much harder, we're going to have a CV joint that's going to last very much longer. It's going to last longer. I was kind of redundant. It's going to last longer, right? If we don't have the heat treatment, let's see if I can get the sun. If we don't have the heat treatment, those bearings, the moment, pretend it's a CV axle. The CV axle is going to be in there, right? And it's going to be putting force on those bearings as it's at different angles, in, out, up, and down, right? It's going to be putting force on those bearings. If the material is not reinforced, those bearings are going to start to eat away at the metal. It's going to make an indentation. Once we have an indentation, those bearings are not going to be hugging the track. We're going to lose our tolerance. And when did I talk about tolerance? Once we lose our tolerance, the bearings are going to start to move around. They're going to start to slap. They're going to start to hit. They're going to start to knock. Once we have that knocking, it's going to propagate the stress, and it's going to propagate the stress into the cage, and that's when we have our failures. So that was a good question about the heat treatments, the spots.
There's another question here, Andres. I would like to know if GSP would be making coil springs.
Ooh, coil springs. That's a question. You wanna answer the coil springs one? Sure. Hold on. That's a question for Mr. Rafael. This one.
What was the question about the coil springs?
If GSP is going to be offering coil springs.
Currently, we don't offer coil springs, but we do. That's something that we can bring up every year. We have a meeting at the end of the year to talk about new products. So that's something that we can address with our management. Thank you for the question.
All right, guys, can you hear me?
Yes, we can hear you, Mr. Doobay.
All right, on behalf of Caribbean Motorspheres, before we bring this webinar to an end, I would just like to extend express gratitude of thanks to the entire team at GSP for a very educational webinar today. I think a lot of questions would have been answered through the entire presentation. I specifically, what stood out for me was the presentation on the CV joint and it becoming, of course, many people would have said that it snapped easily. I think Andres did a good job in explaining why that happens, because a lot of people have the tendency of using pressurized tools to get the CV joints tightened, their wheel lugs tightened, and so on. And I think that is we are heavily misguided on that area. So that stood out very much for me. Overall, I think the presentation was a great one. And again, we would like to express thanks to the entire team.
And thank you very much, Mr. Doobay.
Yes, thank you, Mr. Doobay, for the time and for the wonderful work you're doing in the country of Guyana with the GSP brand. We really appreciate all the work that you've been doing and how you're representing the GSP brand so well in the market. So thank you for all your hard work, your team's hard work of making GSP a brand that now, since I think, when did we start doing business, Mr. Doobay?
Yeah, it's sometime last year.
Sometime last year. So sometime last year, nobody knew about GSP in Guyana. So now I think every shop that we walk into knows about the GSP brand in Guyana, thanks to your efforts and your tremendous amount of work that you've done. And you even have signs in the country of Guyana now that GSP is installed and sold in most places, right?
Yeah.
Correct.
So thank you very much. We are very, very appreciative of all the work that you've done.
All right, ladies and gentlemen, thank you very much for spending some time with us. Just want to say thank you again. If you have any questions, please contact Caribbean Motor Spares and they'll get in contact with us. In a future as well, just before we go on our boxes, be on the lookout. We're going to start adding QR codes on one of the corners. And that's going to have our installation guides, the correct way to install the parts, and also different torque specs and just more information about our products. So it's going to be coming in a little QR code. So just to keep an eye on that. I think that's going to be a very cool addition. I was part of that project and it was very cool to see it be done from start to finish. So again, ladies and gentlemen, thank you very much. Bye, everybody.
Thank you.